Dun, dun, dun. Hello, YouTube. How's it going? I am Carrie Sundra with Alpenglow Industries. Welcome to the weekly Wednesday solder sesh where we come and hang out and put something together. This week I'm super excited because I have Tommy Marshall from Oskitone. Oh, he's on this side with me.
Everybody.
And woohoo!
Hi.
And we're going to be putting together this kit right here, which is his APC, Atari Punk Console. Also in the view here, I have his Poly 555, which is an amazingly fun little synth that that is basically made of 555 timers and is polyphonic. It has like one separate timer circuit for each key, which is simple and overkill and lovely.
Ridiculous. It's a joke instrument. Yeah.
It is. Yes, it is an excellent joke instrument though. And Robin put it together. She soldered it all together. And so, yeah. And she had fun doing that and then tuned it. And so I'm going to, you can now see the extent of my piano skills. Hello,
No pressure.
Bob. Bob's in the comments. Oh, and I'll let you know, Tommy, if there's any like specific like questions and stuff in the comments, so you don't have to like try to also, you know, look at stuff or whatever. So cool. Okay, here we go. The pressure is on. I've never done this live before, so I'm probably going to screw it up. All right.
Well played.
There you go. That is chopsticks. Hello, Brent. It's good to see you. So yes, that is the extent of my piano playing. I think all of the other songs I know are only one tone at a time, so they don't show it off quite as well.
and Carrie, how many years of piano lessons was that?
Boy.
How many years were paid for chopsticks there? Was that 4 years?
Oh, well, for chopsticks, I looked it up on the internet like when Robin first put this together, yeah. I looked it up on the internet. And so it was about 5 minutes of YouTube.
Oh, 5 minutes. Okay. Yeah.
And then it was, 5 minutes of YouTube. And then I needed a refresher this week. I really needed to prepare for that recital. And so it was 5 more minutes on YouTube and
10 minutes total.
Maybe 3 practice sessions. Yeah.
You know what? Honestly, that's pretty good. 10 minutes.
It's all about patterns, right? Recognizing patterns and remembering the pattern of the keys. That's what it is for me, at least, because I'm not good enough to associate a sound with a particular key. So for me, it's all what are the position? What is the physical positioning?
The dirty secret of musicianship is that for a lot of instruments, especially like guitars and stuff, it's all just patterns. Like you'll learn like to do this little box or something. Mm-hmm. And then someone will be like, change the key. And you'll be like, brr, and you'll play the same pattern in a different spot.
Nice.
And pianos are not great because this little layout doesn't lend for transposition easily. Transposition is where you change keys because the naturals and the accidentals, the whites and blacks, are in a totally arbitrary thing. And every key kind of looks different, and your fingers do different things, and it's like a muscle memory thing that you either learn or you don't, or maybe it doesn't matter, or maybe you have a keyboard that does a key transpose or something. But anyway, the point is that there are easier instruments for knowing how to play.
For getting into it.
Yeah. Keyboard is good because it's like a known thing, right? Like there's infinite frequencies, and keyboards are like, all right, there's just this many and it's multiplied and they always look like this.
Yeah. Very discreet.
And it's been that way for a long, long time. So like you can look at any keyboard and be like, yeah, I basically know how to play that.
Yeah.
And yeah. Sorry, I interrupted your flow. Keep going.
No, it's all good. It's all good. I mean, we're here to chat and learn about new things. So that's all part of the process. So I'm gonna get down to, I'm gonna start to solder up the APC while we do a little bit of chatting. Thank you. And yeah, I'm like, so I'm super curious about so many things. So first, maybe tell us in general, like how did you get started on the whole 555 musical instrument kit? Like kit track, right?
Track.
Because it is, yes, it's very much a track, right? You now have how many 555 timer based instruments?
I have 2 that I'm selling, and probably 3 if you count the old OK instruments, and 4 if you count.
What happened to the old OK instruments?
They were real hard to put together. They took a long time, and I thought the ROI on them as a maker was real low. Yep. I thought if you're spending a long time on something, it should give you more. And of course, as a one-person maker business, I fielded all the support questions. So like,
yes.
You know, I saw just the most earnest effort not get rewarded, and all these questions that were like, I should have just designed this better. I should have made this a lot easier for folks to put together. But I do still want to like return, right? I mean, the OKs.
That was like the first thing that you put out, right?
Yeah. So it was a real learning exercise.
Cool.
And I hope that everything that I make, as I'm sure we all hope, I get to learn from the previous things. You know what I mean? So I hope that I learned from the OK's failures and put those lessons into the Poly 555 and now the new Scout thing, which I just launched the other day.
Yeah. Well, I mean, the Poly 555 was pretty easy going together, right?
Oh,
Robin?
yeah.
Like, yeah.
I had a great time soldering it.
How long did it take you, Robin?
Yeah. Like a day.
Yeah, I think that's about right.
Yeah. So like all told, like 4 or 5 hours ish.
4 or 5 hours.
Yeah.
I think that's right. It takes me like 5 hours, and I kind of watch TV while I do it. Somebody told me he put it together in 3. I think he must be very fast. He's got some techniques I don't know about. Yeah, cool. 5. So what are you doing right now?
What inspired you to make your first 555 instrument?
Well,
take us down the twisted path of your brain.
What can I say? I learned how to solder. 2013ish. I don't know. Whatever. A little while ago. I wanted a hobby that was technical, that didn't use a computer.
Yeah.
And electronics fits the bill. And so I did various, I did the things that hobbyists do. I did various kits and stuff like this, and I started building my own circuits on breadboards. And one of the first things that folks will do is like, blink an LED.
Yep.
It turns out if you blink it real fast, and instead of an LED, it's hooked up to a speaker, you get a little tone. And it turns out that if you give it the right components, you can fix the frequency of that tone. And I'm a musician, so I put the things together, and I was like, okay, I'll just make some instruments with these things. The OK, which we mentioned before and looks like this.
I love that it's called the OK, by the way.
The OK too. It's a ridiculous thing. Great. It's a chunky boy. But this
really, I just want something that's big and that says OK on it because it makes me happy, right? Like,
I think that was the appeal of it. Yeah. It's totally a thing that you make and then you put on your shelf, and it's like a little conversation piece. I think the Poly 555 is also a conversation piece, but probably for different reasons. And you asked about 555 timers.
Yeah.
I've used them because that's what I was kind of familiar with, but there are other ways to make square waves. And I've made different like weird one-off things with different ways. Schmidt triggers, stuff like this. Hex inverters. Quiz me later on what the CD 4000 numbers are for these, because I don't remember.
SN74, blah, blah, blah.
Yeah,
blah.
something like that. 40. There are definitely easier ways to make square waves. I've liked the 555 because it's kind of like a running joke within the electronics community. It's like, you know, for folks who don't know, it's like you'll see anything, anywhere, and there will always be one comment that's like, I should have used a 555. Like, no matter what it is, save the world. I could have done it with 555.
I mean, you know, you can really do anything with a 555 timer. I think that's the main theme, right? It's just like any circuit that exists could probably be made using a 555 timer. Yeah. You
and I are live streaming right now on just 2 555 timers.
Right.
They're very powerful. So I've liked them just for that kind of joke appeal, but I'm whatever about them. I'm ready to move on from them.
Yeah.
This thing that I launched recently, the Scout.
Yeah. Tell us about that.
This uses 18 mega 328.
Oh, okay, yeah. So the same processor that's in the Arduino Uno and a lot of their other boards. Yep.
Yeah. So, you know, I've whenever I launch a thing, I write up a real long blog post about everything I learned. And then I always put like a what's next section at the end. And for the last couple 555 things, I'm always like, what's next? Hopefully nothing like this. So we'll see if I ever make another thing. I think they're still cool. I still might.
Cool.
I like the thing that you're putting together right now. Shall we talk about the APC?
Yeah, let's talk about the APC. So I've basically been looking, so you have some really nice instructions up on the GitHub page, and we have those on a screen up here. So I've been looking at those to see which component goes where. And I have, you know, all my components. You probably saw the little tray at the beginning. So I separated them all out according to, you know, the different ones. So each different component got its own little piece in the tray. And yeah, and so now I am matching the capacitors. Through-hole capacitors will oftentimes have a number for their value written on them. And it's probably, I don't know, let's see. We didn't like fully set up microscope cam this time. We can try it. Let's see if we, where am I in microscope cam? There we go. Oh yeah, we don't have a lot of light here. Let's see.
I think that's pretty good. Pretty legible.
So yeah, you can see like the 103 written there for that capacitor, and that one is the 0.01 microfarad, which goes to C101. So yeah, so that's what I'm basically doing, is just matching the two capacitors. And I already soldered the two resistors. I'll switch back. We have lots of different camera setups going on here. And yeah.
Very, very professional setup there. I like that microscope action.
It's nice. We're still working on it a little bit. It's still like a bit of a work in progress, but we're getting there with our different video camera setups.
Yeah,
I'm glad to bring you all the hot soldering action from every angle.
That's what the folks are here for.
That's right. We want to see some soldering.
I'm glad that kit came with those particular caps. I've switched to a different distributor, and and the writing on it's microscopic. It's way smaller. So I think that might have been harder if I made that kit with some different caps.
Yeah, I wish that yeah, it's hard because you think you're getting like the same thing, and then a small difference like that can really like make a big impact for people building your kit, right? Yeah. And like it's also hard if you have like surface mount components to know whether the like resistor markings are on them and stuff like that, because that stuff isn't always like, they don't generally put that in the specifications a lot of times. So yeah, it can be hard to source like a part with the same style of markings.
Yeah.
Yep.
Yeah. Do they put that in the data sheet anywhere? Like, is that ever a thing that DigiKey will tell me about? Like how hard do I got to work to see the writing on these things?
Yeah, right. To see the writing on the resistor. So what would be super handy is if there was a parametric search option for that in DigiKey's search. I don't think there is. At least there didn't used to be. I haven't checked recently. But that would be the handiest thing, because then you could just check a box and it would be done for you. But in the data sheet, yes, there are, in more modern data sheets, they will generally tell you if the code is on it, but you have to like click all the way into the data sheet in order to figure that out. So and you know, is it on the top of the data sheet, or did they just use like one stock photo for all of their different resistors, right? And so is the photo representative? Do they even have a photo, or is it just drawings? Is it at the beginning? Is it at the end? It can take a lot of digging, sadly. Yeah. Yeah,
I believe all that. It's good to know that it's probably in the data sheet. I think that makes sense. That would be a thing that they would list.
Not always, but yes, it is more, and increasingly there is actually more and more information available in the data sheet. Ooh, this is let's see, where are we? Capacitor, there we go. I am right now installing the little electrolytic capacitor here. Hard to see, black on black background. There we go. And so these capacitors are directional, so it is important to have the minus on the minus and the plus on the plus. And that's a good point. Okay, so there's a dot on the board, and then there's a white section. We are looking, here, I'll put it so that you can actually read it a little bit maybe. So C103 right here. So there's the white section, and then there's this pin, which has like a little dot by it. I am guessing that the white section is the minus.
The white section goes to is there a white stripe on the cap?
Yes, exactly. Yeah, and the white stripe is the minus. Match the capacitor's white stripe to the white part of the footprint. This is why we read the instructions.
Close call.
Yeah, so there we go. Cool. So yes, capacitors, capacitors generally the minus side is marked. So there we go. We can stick that guy in. And I always like bend the leads out just a little bit on capacitors and resistors to keep them in place. Other components, you can't do that because you might actually break something. But
yeah, I've learned that the hard way.
Yeah, right. Yeah, LEDs, I don't generally bend the leads.
Really?
Yeah. Well, they actually go through when you like look, when you look at the LED on the inside, they, I've bent LED pins perhaps a little bit too aggressively, and actually like it's transmitted all the way through the case into the circuit, and it's like busted the LED.
Interesting.
Which is very, very sad.
How big were the LEDs? Was it like?
I want to say it was the 3mm ones.
Yeah.
I don't think I've ever done that with a 5mm.
I believe that. That's interesting. I'm gonna be a little more cautious now.
I'll sometimes bend LEDs. Well, actually, hey, there's an LED here. Let's do it with this one. This is a 5. So LED flat side goes to the flat side of the package, which can sometimes be really hard to see, and you might need like a lot of light. But this side is the flat side over here, and that is generally the short leg. So we'll stick it in that way. So for LEDs, so LED leads are kind of rectangular in cross section. They have, they're not like perfectly square, right? And so they have like a flatter side to them. And so I will bend LEDs instead of bending them apart like I do with resistors or capacitors to hold them in place. Yeah. I will take the two, let's see if I can get this in the camera. I would take the two LED leads and I'll bend them like that instead of like that. Because I feel like that stresses them a little bit less because it's you're bending it on the longer, flatter side of that lead. So I feel like it doesn't stress it. It doesn't transmit the stress through the legs as much. All right. Hello. So we got some comments here that I'll go ahead and read while I'm bending these LED leads. So Bob says he studied 2 years of piano before high school. So excellent. And he's also very excited about the Poly 555 and is saving up to get one of those sometime. And yeah, he also says that LEDs often have stiffer wires than passives, resistors, and capacitors. Yep, I totally agree with that. And then Dan Delaney says hello. Hello, Dan.
Hey.
So I bend LEDs on the narrow direction. Yeah, it'll be, let me see if I can actually do like a little bit of a drawing here. It's difficult to explain. Thank you.
Y'all have good eyes. I'm looking at an LED now. I'm like,
so like, oh, that's a little zoomed in. Hang on, we'll do this here. So we have LED. Am I in? There we go. Okay, that's cool. So the LED leads, they generally look like this. If you're like looking down the lead. So I'll bend them this way, like that. That's how I'll do them because they just bend a little bit nicer that way.
Yeah.
Yeah. Yeah. And yeah, I don't know. It's just, I guess it's something that I've picked up from a lot of soldering that I just kind of do automatically now. So yeah, Bob, I'm not sure if that's what you were referring to by the narrow direction, but that's the way I do it.
I think, yeah, that seemed like the narrow direction to me.
Cool. Yeah. So okay. So more APC chat. So APC stands for Atari Punk Console.
Correct.
And is basically like used to make fun and obnoxious Atari-like sounds. Yeah.
That's right. I agree with Bob. Your drawings were a great aid. I thought that was a great informational session.
Excellent.
Yeah, APC makes some annoying sounds. It was made famous by Forrest Mims.
Oh yes.
In one of his books for Radio Shack, long ago.
Nice.
70s, I think. And yeah, it's fun. It's obnoxious.
Nice. I can't wait. So I've said this before on previous streams, but my mom, like, she just hated nothing more than repetitive, like 8-bit arcade noises. Like, they drove her crazy. And so, like, I wasn't allowed to have a normal Nintendo console as a kid. I finally was able to get a Game Boy, pretty much because my dad got it for me.
Yeah.
And but I used to be forced to wear the headphones a lot so that she didn't have to hear all of the noises, which, for me was like, the key part of the game, right? Like that was some of the best parts, was all the fun noises. So the pot was really nice. This is just like a little trimmer pot, I think, our V103 here. And that was nice because it just snapped right in. So don't have to worry about like holding it really. Just does it itself. I love components like that.
Yeah, me too. That's the same pot that I used in the Poly 555. I think for this kit, I tried to use as many parts as I already had.
Yeah.
Makes sense. I have 1,000 of these little pots, and I was like, yep, this is getting one too.
Nice. So now I'm soldering in the little switch, and this guy I do have to hold in. So I'm gonna do our normal trick. Now this one is another one of those where I'm holding it in on this side by the shield. So I want to make sure to not solder as I'm holding it in the shield pin, because that would get hot and I'd burn my finger. So, not that I've ever made that mistake before. So I'm going to choose one of these other pins to solder, and I'm just going to kind of tack it like that. So super, super crappy solder job to just hold it in place temporarily. And now we're going to solder. Now we can solder the shield pins because I'm not touching them anymore.
And you call that technique the blob, right?
Yeah, there's probably a name for it that I don't know. But when I need to hold something in with one hand and solder it, I basically kind of like purposefully, I make what I know is not going to be a great solder joint. I put a blob of solder on the tip of the iron, and then I just, kind of touch that to the pin in the pad. And when you do that, usually all of the flux inside that ball of solder kind of burns off because you're not adding it all at the same time as the heat. You're kind of cooking that blob on the tip of the iron while you put it on the board and stuff like that. So it's not a great solder joint because that flux cooks off. But it's generally good enough to just like tack the part in place. So then you go over and solder the other leads, and always coming back to that one to reflow it with a little bit of fresh solder, because then that makes it all nice and good. Yeah. All right. Boy, this is we're definitely going to finish this today. I'm excited. I haven't had a one-day kit in a while. Cool. I'm also being bad, and I'm not explicitly following the instructions online. I know. I'm kind of getting a little bit cocky here, and I'm like, oh, well, that one's obviously an LED, and there's only one, and this one's obviously a chip, and there's only one. So
hubris.
Yeah, hopefully that's not going to bite me in the butt.
I have a feeling it's in good hands here.
Good hands? Okay, cool. I generally solder things from like smallest to biggest.
Yeah.
And you usually can't go wrong with that technique.
I've been trying a new thing with my instructions where I have folks assemble them for kind of optimizing for feedback loops. You know what I mean? Like do just enough to light up an LED. Test the LED. Did it work? If not, go back and fix some stuff. Okay, next, solder some more things in, make a sound. Did you hear a sound? If not, go back. And so that at each step of, I don't know, hopefully no more than a handful of components, there's like a very clear yes or no. Did this work? Did
it work?
Yeah. Nice. And that's one of the lessons that I learned from the OK. People would spend 3 hours making this thing, and then it wouldn't work.
Yeah.
And then they would email and be like, well, why? And I would be like, go back and check the 100 things you did. Sorry.
Right.
So like the Poly 555 that Robin put together.
You do one whole circuit first, right?
Yeah, you do one whole. It's totally like hook up the battery, light an LED, make the first circuit, light its LED, make a sound with it. I think it's a bunch of stuff. It's a bunch of like real like incremental things with very clear yes no tests, and then at the end it's like, okay, now do the rest.
Yeah.
Which is the bulk of the work. But like once you get there, hopefully you know like conceptually what it all means.
Well, and because you've done one right, then
Right.
if something else is wrong, you have that experience to draw upon, and you're like, okay, well, I did this right. Now, like, if I compare these two, what is the difference, right?
Yeah. What did I do right here that I did wrong there?
Yeah.
I think I mean, you know this too. Like it feels good to have things go right.
Yeah.
And so like the more opportunities you can give to somebody to have that little like aha moment. I blinked an LED.
Yeah.
Feels good. So it kind of, I don't know, selfishly kind of like it multiplies the positive user experiences.
I like that. Yeah. No, it's definitely true. That's something that I hadn't really thought about it from that perspective before, but I think that's a really good way to think about it. Just like, yeah, reinforcing good experiences and also like encouraging somebody to continue, like because you had this small positive experience at the beginning. Yeah.
All right, let's watch you pop this this jack in there.
I know this is interesting. So it's taken me like there's a little bit of force involved here. Oh, there we go. Got it. Not all the way. There we go. So what I did, you know, these like mounting pins here are the ones that are bent and the ones that provide the snapping force into the PCB. And these three just go straight through and you just solder those. But I basically put those in first, made sure that those were lined up because I didn't want them to be not lined up and then to snap this in and have them be all tweaked, have them go, right?
Yeah.
That's no good. So I was careful to put those in first, make sure that those are just like a little bit in the holes. And so it's, you know, it's a little bit off kilter like that when you do that. But then I was like, well, if I just kind of like rock this into place. And I think, yeah, on that one, and I think on this one as well, I am going to have to like push these in a little bit. And so I think I'll actually do that with a pair of, do I have a pair of pliers? Yeah. Maybe I'll just do it with my fingers.
Yeah, you can.
No problem. Who needs tools when you got fingers?
Yeah, I do that too with those. Yeah. I think getting those pots in there might be the trickiest part of this little kit.
Yeah, I agree. It's the only thing I've had to kind of like stop and think about so far and kind of, you know, be strategic about. But it definitely helped pre-bending those. Now, like I have much greater confidence that everything is lined up and in. And so now I think I should just be able to push it. Yep. All the way in.
Yeah.
There we go.
I've learned the hard way that you cannot brute force those in. You can't just like put it where you think it'll be and then push real hard.
Yeah.
It's not a good idea.
No.
Learn from my failures here, everybody.
Well, I mean, once they're in, it's super nice, right? Because now I don't have to try to hold them in while I'm, you know, doing this or anything like that. And actually for this one now, I might go to this vise. Just so that it's now nice and flat and not at a weird angle up in the air. So now I can solder those in pretty well.
How do you like this vise? I see people use it. It looks cool. It doesn't tip over. It looks like it would.
It's heavy.
Oh.
It is pretty. It's like a little solid chunk of metal.
Yeah.
And so yeah, that's why it doesn't tip over. I do like them. I have only recently started using them. And again, like I probably like you, I was like, oh, I see that people on the internet like really like this. Well, I'll give it a go, right?
Yeah.
They are kind of expensive. I think that they're like $60.
Yeah.
So that was like a little bit of a pause for me because you can definitely get like different kinds of like different Panavices and like other little vice things for a lot cheaper for like in the $20 range and stuff like that. But you know, I do kind of like it. It's It's definitely sturdy. My only kind of small beef here. Let me finish soldering this before I forget that I haven't soldered this one yet.
Sorry, I'm
no. That's you're fine. You're fine. I'm getting better at this multitasking thing, but not perfect.
Yeah.
So that's hot. Soldering is hot. Newsflash. So yeah, the only thing that's kind of weird about this is that you have to like pull this up with your hands, this top part up, and you put the board between these in this little rubbery section, and then you like screw this down. So it's a little like I wish on two sides maybe there was like something that stuck out so that it was like a little bit easier to pull apart for when you reinsert the board. That's my only gripe about it. Otherwise, it's pretty good. And it's nice that you can grab onto like board edges or small little rail sections or bigger sections if you have like a large board that you're kind of like cantilevering out. It's surprisingly versatile. Yeah. All right. I think we're just down to the speaker.
Here we go.
Oh, and yeah, the battery too. We'll do that last. There's no round silk screen. So I am assuming that it is on. Hang on, let me look at the actual. Yes, I'm assuming it's on the top as well because that's where all of the openings and stuff are. So, and speakers are directional, pluses to plus, minuses to minus. All right. And this, let's see. So yeah, the speaker obviously, like, well, maybe not obviously, but you can't bend those pins because that could, who knows how those are attached internally to the speaker, and that could potentially damage them. And also they're like really big pins, so they would be hard to bend and you'd have to use a lot of force. So of course, I probably should have done this before the pots, because now they're kind of, if these guys weren't sticking up, then I could just sort of lie it flat on the bench. But, that's okay. That's part of learning. That's why, we sometimes have things like rolls of tape here. So you can just like space things, although the tape might not be the perfect tool. But at least now I can kind of just keep some pressure on the speaker underneath while I do that tacking on this side. Again, not a very good joint, but that's okay. Now I'm just gonna check. And yeah, it looks like, so the speaker has like little feet. There's like a little gap that's supposed to be there, it looks like, underneath it. Yeah. Creates like maybe a little bit of resonance or something. Cool. So now I will go back and solder this guy. And then go back and solder this guy. Cool. So are all APC circuits like pretty much the same? Are they all that same forced MIMS, or do people kind of like riff and do their own like little modifications to them?
People like to mod it. This is the classic interpretation. But yeah, people like to mod it. More resistors, more little like weird things to touch. But I think anything that says it's an APC is basically the same circuit. And the circuit is two 555s. One is an A-stable. One is like a pulse train, so frequency, and then the other is it's like a one shot. It's like just one pulse. So every time it's hit, it does just one thing.
Yeah.
And then the idea is that like one will be pitched and the other will be kind of like, I don't know, timbre, something, and the two together do weird things. Unexpected.
Cool.
Force MIMS called it a stepped tone generator.
Yes. Okay.
And people called it an Atari Punk Console because it kind of sounds like I don't know. Kind of sounds like an 8-bit version of like a bomb falling or something. Yeah.
Like,
Yeah, kind of.
So Bob asks, so you have a 556, dual 555s, and a 14-pin dip.
That sounds right. Is it 14?
Yeah, I think so. 1, 2,
right.
3, 4, 5, 6, 7. Yep. So as is the case with most fresh dips, their legs, you might be able to see it here, maybe dark background for this one. So they're a little bit splayed out, like they're not perfectly at 90 degrees there. And so that makes them hard to insert in the socket the very first time. So I always like to do this little like pressing thing where you just kind of roll it just a little bit on the edge so that you bend all the leads over a little bit. And I do that to both sides, and it's like just a super little bit. And, sometimes I'll have to go over it again if I didn't do it enough or whatever, but that helps align them all so that you don't accidentally get one out of the socket and have it go all first time, which is always a bummer.
Yeah, that is a good way to do that. If you find yourself doing this a lot, or you find yourself working with dips like this a lot, you can get a tool like this, which is like a straightening tool. You ever use one of these, Carrie?
I don't think so. What?
Yeah,
no.
Well, like,
that is a tool I'm unfamiliar with.
It's got yeah, it looks like it's got these channels on the side, and you put the chip in like that. And then you close it. Okay. And the idea is that it just sinks them into place.
Dude, nice. We need one of those. Yeah.
It's like $5. It's probably not better than your technique right there, but it is. It's faster, and it gets a lot of the job done.
Yeah.
Because sometimes you'll get ICs that are like real obtuse.
Yes. And the ones that have more than 14 pins, it can be very difficult to get them all. You kind of sometimes wind up with the ones on either end being bent in, but not the ones in the middle you don't quite get, and stuff like that. So yeah, this is good when pins are kind of like cattywonk. Yeah. Oh yeah.
And this, I don't know, you can imagine.
And Bob says that they handle wide dips too. So that's nice. Yeah.
Oh, maybe that's what the other side of this is for. Oh.
There you go.
There you go.
Learn something. Awesome. Okay, so let's see. Oh yes, don't bend the speaker's leads. Good. So let's see. I am going to solder the wires, and I saw that you include holes here for strain relief, which is super cool. That's always nice, and something that I forget to do in my boards sometimes. So it's always nice to have a reminder. So feed it through its holes. So let's see, do we have... I'm guessing that we want to feed them from the bottom to the top and then solder them over like this.
I'm trying not to tell you what to do.
It. I kind of want to see a photo. Let's see. Hold on. Yeah, because it might make a difference whether the wires exit the bottom or the top of this board for routing purposes. So
there is a photo.
I'm doing it right. Yay.
Of the finished PCB at the top. But there could be like step-by-step photos, which isn't a bad idea. That's good. That's cool.
This is a small enough board though, that I think you're fine with just one photo. Okay, so now those are bent over, and I'm going to pull this through a little bit just so these guys kind of are more or less in their final resting position. Cool. Bend those over like that. Nice. And making sure that red is 2+ and black is 2-. Cool.
One reason I like those relief holes on the PCB is that it kind of helps hold it in place while you're soldering.
Yes. Yeah.
Without those, you're kind of like, you're trying to like bind or clip it in, or you're doing a blob, or you're doing a tack or something. So the relief is nice because it's a mechanical thing, but also I think it helps assembly too.
Yeah.
If you can spare the space on the board, I think it's always nice.
Yeah. So we recently had a tantalum capacitor blowout.
Oh, God.
I know, right? So I'm like, I am now like triply checking tantalum capacitors. I really hope I have mine in the right way. I think I do. I think I do from the instructions, but I don't know. The one in your picture almost looks different, maybe. But I don't know if I want to second guess myself right now.
Let's see your board again.
Let's see. So I have the minus on the side next to the speaker.
I think that's right.
We might not be able to focus very much closer than that. But I did. It definitely, the white is to white. Yeah. So hoping that I don't blow things up.
Bob, there's electrolytic. There's a couple ceramics on there too.
Yep. Just one electrolytic, one tiny one. So cool. Well, shoot. Should we try it? Robin definitely has some PTSD from that. From
it was a damn projectile.
It was a projectile. All right. Bzz. Come on, get in there. Okay. And I think our switch was to the off position, probably, since nothing's happening. Whee. I think it's good.
Do you hear anything?
I hear a little bit.
So RV103 is volume. So you can try turning it up. It's a quiet thing. Thankfully.
My mom would approve.
Yeah.
Oh, this is better.
Can I make it better?
Yeah. This is pretty great. Oh, it's cranked to 11.
Yeah, Nigel Tufnell would like that. Yeah.
Ooh. No. I know. Oh, okay, now I'm gonna try the other one. So that one adjusts, yeah, more tone and pitch. Oh, that's fun. That is definitely fun. All right, let's put it in this case. So I have some questions about your mad 3D modeling skills here.
Yeah,
Yes, I am very impressed with this case. I'm going to zoom out just a little bit so we can see more of it. So first of all, like what printer do you have? Because I'm always interested to hear what printers people like.
I got one of these Prusas, one of the bigger ones. Not the latest, it's a couple gens old. I like a Prusa. Mm-hmm. That is my second. All of that is in PLA, which is the standard, relatively kind of cheap stuff.
Yep.
Yeah.
So the thing that I liked about this so much was that this slide is really quite nice. And like I look at this and I'm like, man, if I tried to print this, I feel like that undercling, or that, the under the lip would be all sorts of crappy, and I'd have to like clean it out, and it would just never quite work very well. So, when I got this and it just slid so smoothly, I was just like, dang, that's impressive. So yeah, can you share any like tips or tricks you have for making parts that fit together so nicely? And do you have to do any finishing to these?
I try very, very hard to design things that print nicely and don't require a lot of post work.
Yep.
Rewind. When I design kits, I'm kind of designing for like a couple different audiences. Mm-hmm. One is like the electronics person. Is this easy to solder? 2 is like, is it easy to assemble at the end? And 3 is kind of like also your printer. Like, can your printer do this well? DFM, design for manufacturability. And so what you're appreciating there, and I thank you for appreciating it, is that the tongue and groove joints of that thing, this sort of goes together pretty well. And it goes together pretty well because there's this trick you can do where if you ever have to print something that goes out, instead of printing it as a T like this, you print it at like a 45-degree angle. Yeah.
Yeah. Yep.
So there's that trick a lot.
Okay. Yeah. Yeah. Now I can kind of see that a little bit in the profile.
Yeah.
Yeah.
The Scout, its enclosure kind of snaps together. But it uses the same tongue and groove joints with a lot of 45-degree angles. The last thing you want to be doing is like cutting out supports from like very tiny places.
Yeah.
A lot of things that I do kind of unfortunately have to have supports because they're weird. But whenever I do that, I try to make them big things that you can kind of clunk out easily, or maybe things that don't really matter. A joint like that needs to be really like real tidy.
Yeah.
Because if you're anything like me, after you put this together, like you'll use that thing as a sort of like fidget. Like you'll hold this thing and you'll just kind of do this. And this is like, I don't know, this became the toy for me, just doing this.
Nice. So now I gotta fit the little switch in, which I think goes in that way. That seems to be proper. Yes.
Yeah.
Cool.
I'm curious what you would call a piece like that. There's this adage that like one of the hardest things in engineering is naming things. I had the hardest time naming this little piece.
From an electronics perspective, I would call it a switch cap.
Switch cap.
Yep. That is generally like now. Slight caveat. This is super interesting as well, because you have a vertical switch here, and yet you have a right angle switch. The right angle switch cap. So that right angle switch cap actually keys in here to the vertical switch, and so that is really interesting too, because like I would never have thought of doing that way at all, because I would have just been like, oh, well, I'm just going to get a right angle switch.
Yeah.
And
I think that would be the smart thing to do. So let me share a fun fact about my version of APC. And it relates to the Poly 555. So the Poly 555, and I have some visual aid too. Its PCB looks like this.
Yeah.
It's L-shaped.
Here, let's make you big. If you can
the Poly 555 has an L-shaped PCB, and it's real big and expensive.
Yeah.
And the thing that fab houses will do is they don't care if your thing is L-shaped or heart-shaped or whatever shape, you get charged by the rectangle.
Yep.
So I was getting charged for this big chunk of space that I wasn't using. I was wasting money. So what I did was I literally just grabbed that Radio Shack book. I was like, what is a circuit that I know that everybody will know? I very quickly did the step tone generator, and I threw it in that corner.
Nice.
Nice. And I basically did nothing else. Like I kind of changed the pots on it, but it worked, and it was like good enough for me. And it existed like this, just in PCB form, for like 100 of these. So I probably had I had a lot of these PCBs before I ever started on the design for it.
Bold, very bold. I like it.
Brazen. And so that is why that switch is kind of weird, because I kind of thought that I would have a switch that like exposed out of the top of the thing. Like the switch is right here.
Yeah.
But it's a weird spot. And to have that switch exposed out of the top, I think would have been ugly. And so I made it instead exposed out the side. Yeah. And so, yeah, it's this switch cap, as you say. Yeah. I call it a clutch because it like clutched onto the actuator of the thing. I was careful not to call it a switch itself because it's not switching anything. It's kind of like an actuator on the actuator or something. Yeah. I think cat makes sense.
Switch actuator is also something I believe I've heard for this type of thing.
Really?
Especially when it's something like this where you're translating motion into a different plane. Because like I generally associate switch caps with like just going on the top.
That's what I thought too. I thought a switch cap is a thing that just like.
Yeah. So I think actually actuator might be the more proper term for it.
But I thought that an actuator is the name of the part that sticks out of the switch too. This thing.
Yeah.
Naming stuff is hard.
It is. It is. Yeah. It's hard to search for things too when you know what you're looking for, but you don't know what it's called by the people who are selling it.
Yeah.
Like learning terminology can be a real challenge. Yeah.
Yeah. This is something that I struggle with because I'm not an industrial designer. Like I'm not an electrical engineer. I don't really know anything about anything.
Well, you're doing a great job at both. So.
And I find myself just making up words all the time, and like my code is just littered with these words that probably don't mean anything to anybody else. And I'm like, if somebody else looks at this code, I hope they understand this. I hope they can get it. But anyway, that's a quick story about the.
Nice.
I don't know that eccentricity that you just.
I like it. So I also have an L-shaped board, and I did not come up with something as clever as your solution.
What'd you do?
I panelized it myself, and I order them as a panel. So I panelized it with the cutouts. So let me go back to my drawing.
Yeah.
My sketch here. So yeah, my board was it was kind of shaped more like a flag, like that. And yeah, let's see about make it that bolder a little bit. So and so I was able to nest another one, and I did a little bit of fudging on the board dimensions so that I could nest them like this. Because the same thing, like those boards were going to cost me almost twice as much money if I didn't do that.
Yeah.
And I did get the prototypes made by Osh Park. And it was funny. Like I even got a comment after I had ordered them, like, so whoever processed the order was like, "Oh, nice nesting." Like,
yeah. Respect.
Yeah. So that was cool. But Wait. Pencil.
You were holding
got it. Sorry. Yeah, I'm like, what's going on? What am I supposed to be doing? Cool. All right. So like this went together super well. I just kind of like made sure that the switch, was like lined up and it popped in. I love that you included mounting holes and aren't even bothering to use them.
Yeah, you could tell. That's a thing I thought that I would have wanted, and I totally didn't.
Yep. And usually it's like, oh crap, I really should have put mounting holes on this, know, and here you got them, and you're like, whatever. I'm slick. I got all this going on. Oh, do I need to cut off?
I think so.
I might need to do that to cut off the speaker leads because
Yeah.
they are sticking up a bit on the back. So yes, let's do that. Let's do that. Cool. Do the nice sliding action. Of course, now I can't do it. I don't know why. There we go. Do I still have something? I have something. I feel like I'm hitting something. Is the board all the way down? Do I have it?
Is it those two guys?
Which two guys?
These ones.
Oh.
They just seem like the.
They might stick up. I can't tell. I feel like Tommy's like, come on.
It's a very small, torturous thing watching somebody assemble something you made and struggling with it. And I'm like, let me help you. But if I did it well, then I shouldn't have to. But
right.
I kind of still want to.
That's okay. So I feel like it might be these fins.
It might be something. Can I read from the instruction manual, because you're kind of doing a lot of jobs here, and
that is true. And reading the instructions is one that I am following.
Slow on the list right now. All right, let me read this too.
Okay.
In the troubleshooting section, it says,
look at that. Enclosure halves aren't sliding together all the way.
Yeah.
Oh. Make sure the PCB is pushed into the enclosure top all the way. Then when sliding bottom enclosure on, try bending it slightly out where its rails meet the PCB.
Does that make sense?
It's
a weird thing to articulate. So this is the enclosure bottom. And I was trying to say, try bending it slightly out like this. Look like that.
Yeah, okay. Yeah. Ooh, got it.
Ooh.
There we go.
Better.
Look at that. Dang. Ooh, and now these knobs. So, knobs, man. I could talk a lot about knobs. So, yeah, I found... so I should there's probably like a lining up thing that I should be doing with these knobs.
Yeah.
Maybe I will read the instructions here so that I don't put them on improperly at first.
I think
it is amazing though how you would think that knobs would come in every single shape, size, texture, color for any kind of, pot length, style, and they just don't. There's like a really small variety of knobs, and the knobs themselves tend to be small. Ones that are like this, that are like, I don't know, like an inch diameter or something, like there aren't a lot of them, and they tend to be those really old school, like metal and Bakelite.
Bakelite, I was gonna say, yeah, Bakelite.
Right? Yeah, they tend to be the Bakelite knobs, and it's probably still the same stock from the 1970s, right?
It might be, yeah.
So yeah, if you want any kind of different kind of knob, you just have to design it yourself.
Thankfully, I apparently really enjoy designing knobs. I spend a lot of time on these. I have previously, all of my things have like odd custom knobs. Mm-hmm. Because I don't like stock stuff. The OK has custom knobs for its things.
Yeah.
The APC has these wheels with spokes and Brody knobs. The Scout has this thing which shares a lot of the same code.
Nice.
Knobs.
Yeah, the yarn twisting tool that I make, I had to make my own knob for that. So, yep. I'm
gonna look that up.
We could grab one. Do you want to grab one of those, Robin?
I want to see what you're talking about. Yeah.
All right. So let me see. Final assembly. Fit the wheels into the cavities on the pot shafts. They should fit perfectly without too much force. I guess so. Okay, so these little raised parts on the knobs go on top. I assume that that's for like speed. I don't know even what you would call it.
Speed,
Speed
speed
mixing,
going, speed turning.
speed turning. Yeah.
You ever use a car? I guess these are on tractors and trucks too.
Right, with the knobs. I think they're illegal. Like, yeah.
Are they really?
I think so. In California, I'm pretty sure that they're illegal on normal like passenger vehicles. Yeah.
Yeah, they're called Brody knobs, and I think aren't they also called like suicide knobs or something?
Probably.
You shouldn't need them on power steering because they're used for like tractors where it's hard to turn the wheel.
Mm-hmm.
And so the idea the reason that I put them on here is because I wanted it to sort of feel like a game controller.
Yeah.
And the game controller, the joysticks have nubs on the top that the top of your thumbs can use.
Yep.
So I was trying to make a thing that you could play in a lot of different ways. You could play with your thumbs using these Brody knobs.
Mm-hmm.
You could like roll it along your palm because the wheels are also exposed on the side.
Yeah.
You do like the classic knob thing where you're manipulated from the top with more of your fingers. So I wanted it to be kind of agnostic about how you're doing it. If that makes sense.
Yeah.
And so this Brody knob, or whatever you want to call it, was my
Bob makes a good point. He says the knobs are often used for disabled drivers, which makes sense.
I think that makes sense.
Yeah. That would be a good non like what's the word that I want? Like
non-reckless.
Non-reckless use. Yes.
Yeah.
Yes. All right. So I'm like probably thinking about this way too much, but I'm like, where do I want these little nubs to be?
Yeah, where do you want them to be?
Nubs. Yeah.
Well, I'll tell you that the shaft, the pot has a 75-degree turn.
75 or 270? 270.
Oh, I meant 75%.
Oh, okay. Yeah.
70.
Yep.
Yeah, thank you. Two ways to say that. And so if it's 50% right in the middle, it's like 12 o'clock.
Mm-hmm.
And so that is where I have been putting it, because
Okay.
I also think that when you're holding it, your thumb will be higher. And so
ergonomics.
So it might make sense to go like this.
Mm-hmm.
You could put it down and then your thumbs are kind of in resting position at the bottom, which might be cool. Try that. You can't do it wrong. If you don't like it, you pop it back out and try it again. The stakes couldn't be lower here.
Right? Okay. I'm gonna try it. Yeah, I'll do it this way. Okay. Popping them on. Come on. I think I feel like they maybe should go on a little bit more, but maybe not. I'm not quite sure how, like, should that stick up that much?
It could be tighter. There's another thing right below the instruction that you read previously is like if the wheels aren't going in all the way.
Oh yeah, there we go. Use a butter knife to pop the wheel off, then reassemble. Yeah. Okay. Yeah.
You can do it later.
I'm all right. I'm all right with how they are right now.
Yeah.
Cool. So
designing these sorts of knobs is interesting because like PLA isn't the best material. It's kind of like a brittle plastic.
Yeah.
And over time it will kind of like erode. So the compromise is like when you first do it, it might be a little too tight.
Mm-hmm. Yeah.
And then over time it kind of like, it's like a basketball shoe. It kind of learns how to fit you better.
Ooh. Get it closer to the mic. Is that coming through?
Yeah, unfortunately.
Unfortunately. Definitely a parental torture device. I love it.
Absolutely, yeah.
That's great. Well, that's a very nice switch feel when that all is said and done. It's like I feel like it's a lot snappier than just having, the basic switch on the circuit board.
I agree. Thank you for saying that. I worked hard to make it feel nice.
Yeah.
It's a bigger surface area. There's like ridges on the side of it that match the ridges on the wheels.
Yeah.
So those things kind of like pull together, hopefully. I don't know.
I like it.
I think it does feel nicer than the actual Switch.
Yeah, no, it definitely has like a really nice tactile feel to it. So these are the knobs that we make for the skein twister. They have like a little bit of just like a tiny little indentation, like ridges on the outside, so that you have just like a little bit of tactile grippiness to it, but not so much that it's like rough feeling. And then so there's just sort of like a little bit of fluting there. Let's see if I might have to like get some more light on this. Yeah, there we go. So the style of potentiometer that we use is one that has a slot in the middle.
Yeah.
So we have like that thin rib in the middle that keys into the slot in order to, have everything line up without us having to really think about it. And then the ribs in the middle are just for support. And like, I don't really even think that we necessarily needed those, but I designed them in because I thought having the extra stability will be good. But I made this this lip, the wall thickness there is pretty big, so it's pretty rigid.
Yeah, those look good. What are those? That's not 3D printed, is it? It looks injection.
So we were printing these ourselves for a long time, and we just started like. Our printers are a little bit old and they're not the most consistent anymore. I mean, they've printed probably like, I don't know, like 200 or 300 knobs or something like that, at least, maybe like 400 or something. But, it just became harder and harder to get them consistent every time. Also, it's a tricky part to print because we print them like this.
Yeah.
So the problem with that is this surface, which is the first layer, is also kind of the most important surface from an aesthetic perspective, because it's the top, it's what you see. And so if you have any issues with first layer, like being a little too low, being a little too high, bed leveling, whatever, you can see it in here. Yeah. So we took a step and we now get them multi-jet fusion printed out of house. And they are like it costs us a little over $3 a knob to do that. We do it through, well, it used to be 3D Hubs, now it's Hubs. I guess Proto Molds bought them. Yeah. But yeah, it's relatively inexpensive, and that's for batches of like only 100. So, but with MJF, you're not going to get a huge cost savings for the more quantities, because it basically takes kind of the same amount of time, same amount of materials. It's not like injection molding where, the molds for these would cost like 10 grand, but each part would be 3 cents. So
how is the white marker done?
By hand, silver paint pen.
Cool. Yeah, that's nice.
Yeah, I messed around with 2-color printing, and my printer just didn't handle it very well. I have a FlashForge, FlashForge Creator Pro, and like there was always like white spooge in the black and black spooge in the white, and it just never turned out very much. So
I think that looks cool. That looks worth it to me, That's
Thanks.
Nice.
Yeah, it was nice to be able to finally have a method of getting these made out of house where they're all totally the same, pretty much. There's like very little variation, and at a price that was affordable for the product.
Yeah.
Because other methods of fabrication, like injection molding, it just was not going to be worth that initial investment at all for, you know, something that you're making like a few hundred of a year, you know? So yeah, the MJF Multi-Jet Fusion it's interesting, relatively new 3D printing process, but kind of bridges that gap a little bit for affordable, low volume production.
Yeah, very, very cool. Thank you for talking about that. I think that's very interesting. That's something I struggle with, like how to make things that look very nice at semi-reasonable cost.
Yeah.
It's tough. This is one of the challenges that we face.
Oh, so Bob asks if the small hole above the right wheel allows us to adjust the volume trim pot. I think it does, yeah? Yeah, nice.
Yeah, good eye, Bob.
Yep. And then the other hole is the on-off LED.
Yay, APC!
APC! Wow, that's totally fun.
I was sweating a little bit, you know. I was worried that it wasn't going to work, so I'm glad that it did work. Yeah, sweet little kid.
Good job. Good job. No, it's a super fun build, and like I also think that it's super approachable for kids, I think, because it's not a kit that has a million different parts, you know,
yeah.
And you have like a lot of really great instant gratification from it. So, you know, yeah, I think that's awesome. So tell us more about the Scout, and like, could you play something on it or the Poly 555 that's better than my stunning rendition of Joysticks?
Poly 555 is this. Yeah, let's do the quick pitches.
Yeah, absolutely.
This is the Poly 555. It looks like this. There are 20 555 circuits there, all identical as keys. Can you hear that?
Yeah, that's good.
It's got this thumb wheel on the side, like it's an old 90s Walkman. It doesn't slide together like the APC, but it uses a lot of the same enclosure parts. It screws together, and there's some like hitches here. So this part's held together right there, and then this screws together. It's basically top and bottom. It's like 20 hours to print. There's a big old speaker in there and a 9-volt battery. Ooh, nice and distorted at the top.
Love it.
Let's work that polyphony, huh? Can you hear?
Yeah.
Can you hear that?
Yeah. I love how there's an LED per key too, so that it, you know.
You gotta know.
Lights up. Yeah.
Next time you have me on, maybe I'll have a better camera setup. It's hard to, but you gotta trust that I was playing that. I could do one blues scale, and it's C blues, and that's the only blues scale I can do. So that is the Poly 555.
I love it.
Available now at Oskitone.com.
Woohoo!
The thing that I launched Monday is called the Scout. Looks like this, much smaller, much cuter. 17 keys, powered by AT Mega 328, which is the same microcontroller used by the Arduino Uno. It is called the Scout because it is my first foray into microcontrollers. Nice. I don't really know much about much, but I knew that I wanted to get away from 555s, and I wanted to make something that could be done in a much shorter time frame. So this takes about 45 minutes to put together, to solder and assemble. It still takes like 9 hours to print because, you know, printers can only go so fast.
Yeah.
That will look familiar to you. So this is the same kind of switch cap, switch clutch, actuator.
Right.
This has a pow pow pow. The volume uses the same code as the APC, but it looks different. Instead of a Brody knob, we have a little dimple, and there's no spokes. but it uses a lot of the same code. It has a line out.
Ooh.
First time playing with like headphone jacks. It's a
Nice.
stereo jack, but it's wired as mono, so you could use headphones. And I tried to make it so that at max volume it won't deafen you.
Right.
It has UART. UART stands for, I don't remember. Do you know?
Universal asynchronous receive transmit, I think.
Ooh, yeah, that's.
I'm not sure if the U is universal or not.
The jack
Sounds good. Totally is, yeah.
Bob asked, does the jack bypass the speaker? It mostly does. There's this like a small hint of the thing still in the speaker when you plug in. It sounds like this. So, when you turn it on, so the APC has its LED exposed, as does the Poly 555. So it's like this.
I love that light pipe action too, by the way. The do I really need a light pipe? No, I'll just like kind of work it into the print.
That's great. I always want a light pipe. There are like things that I keep coming back to. I always want to make real light pipes. If I can figure out a design that uses them well and makes sense to get them manufactured, I probably will, because I just keep coming back to them.
You can buy light pipes too, right? Just like little ones that you press into things.
You know me, I have a disease called not invented here. Which means I want to make everything from scratch. That's why all these knobs are like this. This is why I'm not using like off the shelf MIDI controllers or whatever. But the Scout does not have an exposed LED. Instead, it's kind of a secret thing that when you turn it on, there's like a little thing inside the thing. Also, the speaker is not exposed. The speaker is actually right here, and it uses the keys as a grill. Turn this thing up. Bob asked, does the UART on the Scout allow for reprogramming? It does. You hook up a, I don't have one here, but you hook up like an FTDI cable, sold separately, and you plug it into this, and then your computer talks to it just like an Arduino Uno. And I ship all the chips with a bootloader, so that you can do that. Anyway, it sounds like this. Sounds like this. It is monophonic. Monophonic means one note at a time. This is the same blues scale. It's hard to play like this. But yeah, it's fun. I think it's a nice little kit for I don't know, folks new to electronics and people who are like familiar with Arduino. I hope people like it. I put it out Monday. I'm still kind of promoting it a little bit. Thank you for the opportunity to promote it right here.
Of course.
Yeah. Well, I'm hopeful that people like it, but I'm also hopeful that like it kind of unlocks me to do new weird things. You know what I mean? Like,
absolutely.
Anytime I put something out, people are like, "Can I do MIDI?" And I'm like, it's all analog. Like, it wouldn't be worth it. No, I would need a microcontroller or something. Does it do control voltage? Does it? And people, can it do filters? What about envelopes? This still doesn't really do any of that. But the fact that I'm moving,
it's more an instrument than a synth, right? Like that's how I kind of think of it a little.
Yeah, it's I don't know. It's yeah. Synth is an overloaded word. When you say synth, it means a lot of different things to a lot of different people.
Ooh, you see, I know nothing about this. There's synth drama. I love it. I'm not surprised. I mean, you know, there's knitting drama, there's crocheting drama, there's spinning yarn drama, there's all sorts of drama in every community. So it's like, of course there's like synth drama.
Of course, right.
And discussion about what is the meaning of synth and like, you know, what exactly is the meaning of yarn and what constitutes a fabric. And it's fun having those discussions, right?
Yeah, I bet I love it about as much as you do.
Well, yeah.
But anyway, I'm hopeful that this will unlock some of those things. And I'm also hopeful that it will you know, give me a foundation to start doing weirder things that are less keyboardy. Because, you know, pianos are like the 555 timers to me. It's like a known thing. And there's value in using a thing that is already like has precedent, and people have a general understanding of like the ins and outs of this thing, but we shouldn't be beholden to it. You know, if like the world is our oyster, why shouldn't we do weird stuff?
I like it. Heck yeah.
Maybe I'll do some weird stuff. Or maybe I
think you should do lots of weird stuff.
If people will buy it, I will make it.
Right. I'm like, well, even if people don't buy it, I'll probably still make it.
That's true too, yeah.
But that's not a very good business decision. I don't recommend that, but it does happen sometimes.
Yeah. No, I hear you. It's hard to be both an artist and a business person, you know. It's those two things can be at odds, and when they both meet up, it can be a little awkward.
Yeah. Absolutely.
But anyway, that's that.
Yeah, Bob says there's lots of programming drama. Oh yes, definitely.
Yes, there is. Unfortunately.
There's drama everywhere. Well, cool. Well, this was super fun. Thank you so much for coming on and everything.
Thank you for having me.
Is there anything else that you want to show off or?
I don't think so, but yeah, this was great. I'm so glad that it actually worked. Thank you for having me.
Me too.
Thank you for buying my wacky things.
Yeah, thank you for making your wacky things.
Well, I also want to say, you know, I'm a big fan of you and of Alpenglow, and I recently learned what Alpenglow is.
Ah, yes.
So I love the poetry and the name and the mission, and I'm so excited for, I don't know, your recent like new space, new expansion, your new people. I'm real jazzed about everything that y'all are gonna do, and I'm weird on camera, but I will do this for you because I think you're cool.
well, thank you, because I feel like I am weird on camera too. So thank you for being weird on camera with me. I think it all works out.
Good.
Cool. Well, awesome. Well, definitely we'll definitely keep in touch with each other. And yeah, like for anybody watching and listening, definitely give Tommy at Oskitone a follow. Give him some retweets, some sharing the Scout love. And yeah, and you know, he has really cool things like, you know, the APC wasn't very expensive. So he has a range of stuff on his website, and you even have like a little sequencer that I also got at the same time that was like a pretty inexpensive little kit. So, you know, if you're not quite ready for the Poly 555 yet, there's still a lot of cool stuff you can get. So.
I'm trying to better serve the markets out there. So also, if you like my aesthetic, but you don't see something that is for you, let me know. Whenever people ask me for things that I don't make, first it's annoying because I'm like, I don't make that. But you know, it's like free market research. So just tell me what you want.
I get what you're saying, because it's like, yeah, you can't make everything, right? But some of those things that people like, if somebody keeps bugging you about something over and over again, it like takes a little bit of root and it
There's
starts
demand,
growing into an idea, and like, yeah, there you go. Cool.
Definitely. Thank you, Carrie.
Awesome. Thank you. And thank you everybody for watching. And we will see you next time. Bye.
Bye.